Hey everyone, welcome back to Age and Education channel. Today we shall look into the topic refraction. So as a part of this, the topics that we will be covering would be the definition of refraction, then laws of refraction, about refractive index, also about critical angle and total internal reflection, okay, then about dispersion of light. Okay, after you learn about all this, we can say that we are done with refraction for 7th grade. Okay, so what is refraction? Refraction is bending of light. What is it? Bending of light as it passes from one medium to another with a different optical density. Okay, so reflection is different from refraction. Okay, just don't get confused between reflection and refraction. Okay, refraction comes into account when there are two mediums of different optical density and when the light is trying to pass from one medium to another. Okay, so consider this to be air and this to be water. Okay, so when any light is trying to move from air to water, okay, it gives some bend, it shows some bend, it won't be straight, and because of this bend the size of the ray will also change, right? So this property of bending of light as it passes from one medium to another with a different optical density is called as refraction. Okay, and what happens with this? You can see that the speed of the light changes because of this, right? As you know, in vacuum the light travels faster, right? Because there will be nothing else to come in its way, right? So vacuum can be considered as a medium where light can travel to its maximum extent. Then next, air. So air, how about its density? Will it be more than vacuum? Yes, definitely more than vacuum, but it will be less than water, right? So when you consider this scenario where the light is moving from air to water, right? So air has lesser density as compared to water, right? Lesser density, higher density. Now the light is moving from what? It is moving from lesser density to higher density, right? In this case what happens? The speed of the light slows down and it will bend towards the normal. Okay, so when the light is coming like this, and if this is the normal, okay, this one will bend towards the normal. Okay, so it will move like this. This is the angle of incidence and this is the angle of refraction. Okay, now in the converse scenario where the light moves from higher density to the lower density, then it will move away from the perpendicular, normal rather. Okay, so I will make this concept a bit more clear. Okay, these are the two scenarios. Here you have air and then water. Okay, air has what? It has lesser density, and then comes water which has higher density as compared to air. Okay, actually this density concept will also boil down into refractive index, but I don't want to confuse you at this stage. Okay, I will link this later. I will show you how refractive index and density are related. First of all, it's important that you understand the concept of light bending when while it's moving from from a medium that has lesser density to higher density or higher density to lesser density. Okay, so this is the case where the light is going from lesser density to higher density, and this is the other case where it is going from higher density medium to lower density medium. Okay, first see, this is the incident ray, right? And after this is incident at this point, you draw a normal. Okay, in usual case this should go like this, right? A straight line, but it's not going like that. It is because there is a difference in the optical densities of the medium. So what happens? As it is moving from lesser density to higher density, the speed of the light ray slows down, and this will tend to bend towards the normal. So this is the normal, right? So instead of going like this, it will bend towards the normal. Okay, so if this is the angle of incidence, this will be the angle of refraction. Okay, now here in this case what happens? Again you will have this incident ray, right? Now usually it should go like this, right? So as soon as you have this point, you draw a normal straight line. Okay, so in the previous case this went towards the normal, but now it will go away from the normal. Okay, little bit away from the normal. And here also you will have angle I and angle R. Okay, that is angle of incidence and angle of refraction. So with this you can understand that whenever any light ray travels from lesser density to higher density, it tends to bend towards the normal, and when any light ray is moving from higher density to lower density, it tends to move away from the normal. Okay, with this concept in your mind, you can understand about the concept of total internal reflection. Okay, before that, it is very important to understand the meaning of refractive index, and we shall also look into the laws of refraction. Okay, so we shall look into laws of refraction. What are these laws of refraction? The first law states that the incident ray, the refracted ray, and the normal drawn at the surface of the separation between the medium at the point of incidence all lie in the same plane. Okay, so all these lie on the same plane. Okay, this is the first law of refraction. And how about the second law? Second law has a name to it. Okay, it's also called as Snell's law. What does it state? It states that when the ratio of the sine of angle of incidence, sine I, and angle of refraction for a constant pair of media, okay, for a constant pair of media, that is like if it is between air and water, right, air and some other gas, okay, in this case this ratio will always be same for the pair of media. Okay, so for the air and water pair, the sine I by sine R ratio will be the same. It means that when you do sine I by sine R, consider you get something, some number, right? Sine I by sine R. I don't know if you are aware of these sine things, but just remember, okay, it will all be related to this. Okay, when in a right angle triangle you will have sine theta, cos theta and tan theta. I'm not sure if you are aware or not, but the Snell's law states that the sine of angle of incidence and the sine of angle of refraction, okay, both will be a constant for a pair of media. Okay, now then we will look into refractive index. Okay, and the notation here would be for this one, sorry I forgot to mention, if I say n to 1, it means that the refractive index of the second medium with respect to the first medium. Okay, the refractive index second medium with respect to first medium. Okay, now we shall look into the concept of refractive index, right? So the next topic is refractive index. It is denoted by n. Now to understand this, first of all, you should know that the speed of the light would be maximum in vacuum, right? So apart from vacuum, any other medium you take, the speed of the light definitely decreases. So the next point is speed of the light decreases in any other medium, as compared to speed of the light in vacuum. Okay. Now, how about refractive index then? Now, the refractive index, what it does is, it quantifies. What does the refractive index do? It quantifies as how much speed, like how much the speed of light decreases. Okay, speed of light decreases in a medium compared to vacuum. Okay, medium compared to vacuum, right? I hope everything is clear now, right? So the speed of the light will be to the maximum in the vacuum, and any other medium you consider, the speed of the light is bound to reduce because they'll have some density, right? Because of the density, the speed of the light reduces in any other medium. So the refractive index quantifies as how much the speed of the light decreases in a medium compared to vacuum. Okay, so it is, if you have to write it like n, n is the refractive index and c is the speed of the light. Always speed of the light in general is denoted by c. Okay, so if c is the speed of the light, and speed of the light in where? In vacuum. Okay, in vacuum, and v is the speed of the light in the medium, that you have considered, then n will be the refractive index. N is equal to speed of the light divided by the speed of the light in that medium, and this n is the refractive index. Okay, and more the refractive index, it means greater the bending. Okay, right? So previously I have mentioned this one while defining about the refractive index, have mentioned higher density, lower density. The right term here would be not density. You can say it to be density also, that's nothing wrong. But even if someone says that the medium that has higher refractive index and lower refractive index, then don't get confused. Okay, even if we say higher density or higher refractive index and lower density or lower refractive index, then you should not get confused. Okay, so the thing is that for the higher density, one thing that I want to mention here is that when there is higher density, what happens? Higher density means higher refractive index or lower refractive index? Tell me. Yes, higher refractive index. And when there is lower density, it means lower refractive index. So now if you consider air, okay, air and water, which has a lower refractive index? Obviously it is air, right? So air has lower density and so lower refractive index, right? And how about water? Water has higher density and so it will have higher refractive index, right? So you can substitute the terms lower density and higher density to lower refractive index and higher refractive index too. Okay, both are right, perfectly right. But if you say refractive index, if you use this term, it would be like more related to the concept of light. Okay, now we have learned about this too. Now there are some other concepts like critical angle, total internal reflection and diffraction. We shall look into that in the next video, because I don't want many things to be crammed in your mind in a single video. Okay, I hope everything is clear till now. You just after all this, you revise once about the reflection of the light and find the difference between reflection of the light and refraction of the light, and also see the differences in the laws of reflection and laws of refraction. Okay, and after that I have mentioned about Snell's law too, right? That is the second law of refraction. And apart from that, look into this refractive index concept. Okay, next we will in the next video we shall look into the other concepts of refraction, that is the total internal reflection, critical angle and diffraction, all these. Okay, and in the next video when I do that, the other video would be on the spherical lenses too. Okay, so there are around 3 or 4 more videos, I think. Okay, after that we can wrap up the chapter light. And with this, after you are done with light, you will feel like almost all of the chapters are very easy as compared to light. Okay, so okay then, bye, see you.